Hello, listeners of the Mad Scientist podcast, and welcome to episode 18. This month has been a big one for the show, with a lot of really exciting developments happening for us here. First off, we've been accepted into the Dark Myths Collective, a group of really awesome podcasts that I've been listening to since I started this adventure about a year and a half ago. The site for this podcast collection can be found at darkmyths.org, all one word, and includes such great shows as The Eastern Border, the Nighttime Podcast, Astonishing Legends, History on Fire, Rumor Flies, and a whole slew of others. Give them a listen, because your support of those shows helps to support the Mad Scientist podcast. Dark Myths is really careful about the quality of the shows they accept, and I'm just insanely proud and happy to say that we've gotten their stamp of approval. Anyways, we've gotten so much love and support for the show so far, and it's all been really great and appreciated. This show, as always, wouldn't be possible without you listeners enjoying it, and so please consider reaching out to the show on Twitter, Facebook, Instagram, Patreon, or even just shooting us a quick review on iTunes. I've so far gotten to send out a few stickers to people who have left reviews, and if you want a sticker of the show's logo, send me a message with your review and address, and you'll get your sticker and a hand-drawn doodle by yours truly. We've also had some pretty exciting new developments in terms of the research for this show. So, as many of you listeners know, I actually am a research scientist currently working towards my PhD, and pretty soon I'll have a real job. And so, getting research for this show has been quite difficult for me when it's just been myself working on it. And so the first person that I brought on was Marie Mayhew, who is a phenomenal researcher, my co-host on the Roundtables, and a fellow ARC member from Astonishing Legends. But even just the two of us has been kind of hard. So we've now kind of broadened the research core of this show to include a couple of new people who I would love to give a shout out to. So first off, we have Dr. Dinara Andarova, who is actually one of my good friends, a fellow PhD. She actually has her PhD as opposed to me, who's just working towards it still currently. And she is currently a research chemist in the Boston area. We also have Justin Ramberger and Dan Aceta. And these are two undergraduate researchers who have actually helped me a lot in my research at the lab, and who are two really phenomenal researchers and good friends. And finally, rounding out the research team here, we have Megan Gall, who is one of my good friends and actually played trumpet on the intro track to this show. So Megan has a degree in history from Ithaca College, a master's in social studies education from Hunter, so I'm really excited to have this really great team of people working on this show with me. And of course, we have, as always, Scott, Forrest, and Tess from Astonishing Legends, who have just been overall phenomenal in all aspects of this show coming together. So, last week capped off the series on medical weirdness. I was thinking that an episode on vaccines and the controversy around those topics could be interesting, but honestly, that has been covered so extremely well by documentaries, investigative journalists, and even some other podcasts, that I'm a little hesitant to throw my take on this story and topic if there isn't really anything new for me to put out there. However, if other listeners or people respond to a potential show on vaccines and say, we really want this, then I'm always open to doing topics that people think would be interesting, so please let me know. Anyways, this week's episode will focus on a weird topic that we sort of covered slightly in the roundtables, where I said I would give a better answer. And hopefully, this episode will provide some of those answers. This episode will look at the flat Earth theory, or at least modern views of non-normal Earth theories and the surrounding conspiracy theories that are out there to try and promote these ideas. The Weird Earth topic was one that I had planned on doing for a while with this show, but it was only really until we got a question by listener Sean Locke that this question came up on the episode. He asked why we were so sure that the Earth was solid, as opposed to hollow as some online claim. And the answer I gave was pretty much because science. A not very good answer, I admit, but the one that I gave at that point with the promise of more information to come. And so this episode fulfills that promise, hopefully, allowing for more detailed information on the Earth, why we know it's round, why we know it's not hollow, and how we have pretty much a good idea that Nazis aren't living down there with the lizard people plotting our demise. Welcome to the Mad Scientist Podcast! Today's episode, The Flat Earth Theory. So, in the middle of this week, Shaquille O'Neal came out and said that he believed in the flat earth theory. And when I say in the middle of this week, I mean in the middle of the week that I was writing this episode. He's now joined Kyrie Irving as a contingent of the NBA's Flat Earth Society, I suppose. Although, for what it's worth, considering they are paid to literally shoot a ball into a hoop, it's a little hard to take their opinion on this scientific question seriously. Not trying to throw my lab coat around or anything. I'm just saying is all. Anyways, the flat earth thing and the earth's shape kind of being up for debate has become pretty popular online nowadays. At least if the very frustrating arguments I get into on Reddit are any indication. I think partially this is a mistrust of science generally. Probably because of the sort of anti-basketball jokes I just made, and the sort of pig-headed assumptions about my superior knowledge on this subject compared to the average person. But then again, I don't go around telling professional basketball players how best to score jump shots and shit, so I'm thinking I'm alright on this one. And to be fair, Shaq is extremely well educated actually. He has a PhD, I think he has a couple of master's degrees, and so this isn't to say anything about Shaq's intellect or anything. Just that maybe Shaq is not the perfect person to come to for this answer about, like, why did geologists and basically every scientist agree that the Earth is not flat and that it's not hollow? So, the shape of the Earth is a really interesting thing for conspiracy theories and pseudoscience. To begin with, only a very small part of the population will actually get to see the shape of the Earth with their own eyes, so it makes it a lot easier to start to sow doubt. At the same time, a lot of the evidence for the Earth's shape that most people see or come into contact with during their lifetime comes from the scientific establishment, and even at times from the government. People tend not to trust everything the government tells them. I mean, even sometimes the guy running the government doesn't believe the stuff the government tells him. And just think about all the other stuff people think the government is hiding. If NASA faked the moon landings, how difficult is it to imagine that they're faking the shape of the Earth? Have you ever seen the shape of the Earth with your own eyes? Well, the funny thing is that for a lot of people, the answer to that question might actually be yes, although you may not have noticed it as such at the moment. First off, if you've ever taken a plane ride cross-continent, then you may have actually seen the curvature of the Earth at least a little bit. An even more interesting argument would be to just, like, take a plane and fly all the way around the world. If you keep going in one direction, eventually you'll end up at the same damn starting point. That's a pretty cool trick if the Earth is flat or something. Another one would be to strap a GoPro to a bunch of balloons and let it just fly up into the, upper atmosphere. Something that loads of people have done on YouTube. So just go take a look at that, unless those people are also NASA shills, of course. More down-to-earth arguments, forgive the pun, exist as well. First off, you can see boats dip below the horizon as they sail out towards sea. Try to imagine some scenario where this would be possible on a flat Earth. I suppose one could argue that we're actually on a slightly curved Earth. But again, we have ocean liners that can sail from end to the Earth to the other end of the Earth. There is no terminal point for the Earth's end. So this idea of a flat Earth in the sort of sail off the edge of the Earth mythology isn't really tenable at all in a modern world with shipping and flying and sailing and all kinds of other transport around the globe. Just ask yourself, how the hell would it be possible for it to be simultaneously daytime and nighttime if the sun is the only source of daytime light available to us? Does it make sense that on the surface of the Earth, there could be areas of sunlight and sunset at the exact same moment if the sun was shining onto a flat object? How about how stars change position in the night sky as the Earth rotates? Maybe the best case scenario for this kind of argument is a sort of weird Final Fantasy on the Super Nintendo-esque world map, where if you fly to one end of the flat expanse, you just end up on the other end, where it would connect you linearly. And some of the flat Earth arguments do sort of try to make this claim. However, in some cases of flat or near flat Earth arguments, it isn't so much about the shape of the Earth as it is the shape of the whole universe, or rather the makeup of that universe. For example, if we take the problem of sunlight we just mentioned, well, that's only a problem if you think of a flat Earth existing in a universe, with a sun as some celestial object far away from the planet. What if the Earth was instead part of a number of concentric rings sort of system, with the light from the sun or the moon and the stars only showing up due to light shining from some heavenly plane behind a series of rotating panels above the surface? In other words, Imagine a universe where the Earth's surface is the outer surface of a ring, which faces outwards towards another series of concentric rings, or I guess more accurately, concentric like spheres or concentric bowl shapes. The outermost ring is a bright light, which provides all light in the form of the moon, the stars, the sun, everything. The blackness of space could then be explained as simply another ring in front of the very bright one, with some areas where it is colored and allows in enough light for it to be considered day, and other areas where it is not translucent, and so instead we see night. So in other words, this is sort of like a sliding panel show kind of argument. So you have a back panel that is very, very bright and shining light. You then have a panel in front of that one where the cutouts on that panel are where like the sun or the moon goes through, and the panel itself, maybe there's like extra layers or something, whatever, but the panel itself changes the way that light shines through so that when the panel that looks like daytime is on top of our part of the flat Earth, then it looks like daytime, but when the panel is for nighttime, it looks like nighttime. So the sun and the moon in this case are then simply cutouts from that first ring closest to the Earth, right? And the clouds and weather and whatever would then just be like another ring. In many ways, this argument holds more water even than some of the flat Earth theories out there on the internet. I mean, hell, at least this Cogswell universe accounts for daytime and nighttime happening at different points in the day, while some flat Earth theories just can't. Anyways, how did the flat Earth theory sort of develop over time? This idea of the Earth existing as a flat plane or curved surface is one that dates way back, and is one of the earliest sorts of cosmologies we hear about. The Bible, for example, has the following quote, "Then God said, 'Let there be a firmament in the midst of the waters, and let it divide the waters from the waters.' Thus God made the firmament, and divided the waters which were under the firmament from the waters which were above the firmament, and it was so. And God called the firmament heaven. So the evening and the morning were the second day." End quote. I promise we're not starting Mac Day here, by the way. I realize that quote has been hilariously used in It's Always Sunny. Alright, this quote is more fully described in the Jewish Encyclopedia as a sort of dome-like structure. Quote, "The Hebrews regarded the earth as a plane or a hill figured like a hemisphere, swimming on water. Over this is arched the solid vault of heaven. To this vault are fastened the lights, the stars. So slight is this elevation that birds may rise to it and fly along its expanse." End quote. In this description, the firmament is the vault where the stars and sun are fastened. So kind of like how you could put those glow-in-the-dark stars on your ceiling, it's kind of the same idea. Other ancient religions had similar sorts of ideas. For example, Native American cultures believed that the universe was broken up into an upper, middle, and lower world, which can roughly be translated into ideas of a heavens, an earth, and a hell sort of system. On the other hand, some verses of text from the ancient Hindu religion suggest that the earth is round, although since the entire Hindu cosmology centers around circular cycles of like birth, life, destruction, and rebirth, it's hard to point out exactly what is meant here. A rough translation is, quote, "The living entities residing on Sumera Mountain are always very warm, as at midday, because for them the sun is always overhead. Although the sun moves counterclockwise, facing the constellations, with Sumeru Mountain on its left, it also moves clockwise and appears to have the mountains on its right, because it is influenced by the Daksinavarta wind. People living in countries at points diametrically opposite to where the sun is first seen rising will see the sun setting. And if a straight line were drawn from a point where the sun is at midday, the people in countries at the opposite end of the line would be experiencing midnight. Similarly, if people residing where the sun is setting were to go to countries diametrically opposite, they would not see the sun in the same condition." End quote. That's from the Srimad Bhagavatam, and it's still like a vast oversimplification to say that that means that it was a flat earth, or rather that that was a circular earth or a spherical earth. But it's interesting that they made these observations that there are points where the sun would be setting in some places, but then also rising in others, right? And in general, it's just a vast oversimplification to say that all cultures had this idea of a flat Earth, or that all ideas about cosmology were similar in some ways, as many proposing the flat Earth theory kind of like to say. This idea of a flat Earth in the West really wasn't all that set in stone as people seem to think anyways. In fact, the idea that the people as recent as Columbus believed the Earth was flat is itself considered a modern myth, since the vast majority of ancient scholars believed that the Earth was spherical thanks to the works of a number of the ancient Greek philosophers. For example, Plato and Aristotle both believed the Earth was round, based on the observations of the stars made by seafarers, and Aristotle specifically described some of his evidence for this fact. For example, star clusters behave slightly differently depending on where in the Earth you are, and in particular, even in areas as close as some of the city-states of the ancient Greeks. So as you go towards the equator, constellations will appear to rise higher above the horizon at night on the same days and at the same times, suggesting that your angle to those constellations is different than at some other point. This is not significantly possible on, for example, a flat plane. Another observation Aristotle used to support this notion of a spherical Earth is that a lunar eclipse shows the shape of the Earth's shadow as being a round circle, which only makes sense with a sphere. And remember, thanks to the work of the Greek mathematicians such as those in the school of Pythagoras, we had much of the trigonometric algebra, which allows for us to get some idea of the size of the Earth and its shape from relatively simple math. So first off, we kind of have to explain what trigonometry is, I suppose. Trigonometry literally means the geometry of things with three sides, or the analysis of the geometric shape of the triangle. And because the triangle is composed of like 3 points that are connected by flat lines, or straight lines rather, it becomes really useful for different sorts of mathematics and different ways of like applying math to the physical world. So trigonometry is like the foundation for most of modern physics, most of modern engineering. It's just a super important field. Way more important than it looks as a middle schooler who is failing trigonometry. The Greek astronomer Eratosthenes, in fact, got a rough idea of the circumference of the spherical Earth in 240 BC by using astronomical findings during the summer solstice at different parts of the Earth. This works in the following sort of way. First, we find a particular time of day, in this case the solstice, and then 2 different places, which in the case of Eratosthenes was Syene and Alexandria. We can then measure what angle the sun is at, normal to our particular surface, by looking at the length of shadows cast by the sun on objects, and comparing that to their actual length. In other words, we set up basically like a pole on the ground, and we measure the shadow of that pole. And based on how far that shadow is from the top of that original object, we can then make a triangle, with one end of the triangle being the pole itself, the bottom line being the shadow, and then the distance between the tip of the shadow and the tip of the object being that third point of the triangle. Using trigonometry, we can then get the angle of the sun causing the shadow by comparing those lengths. Now, trigonometry is all about right-angle triangles, which means a triangle that has one edge that makes a 90-degree angle, like a square. The ratio of the arm distances are all then set into required ratios, depending on the angle of the corners around that triangle. And this all works because we have stated that this triangle must have a 90-degree angle. The way these things are related to each other are known as trigonometric functions, which have names like sine, cosine, and tangent, and which relate the 3 sides to each other in relation to their position relative to that one square angle. I'm not trying to teach trigonometry on your way to work here, but basically the ratio of the height of the object to the shadow cast will be equal to the tangent of the angle the sun makes. I will put a drawing of this up on the website for you to check out, by the way. Like, this does not have to be a purely mind experiment here. Okay, so measuring that distance between the top of the object and then where its shadow ends, and then knowing the length of the object itself and the length of the shadow, we can approximately get some idea of the angle between where that tip of the object is and where the tip of the shadow is. And if we know that angle at 2 different points, then we can basically draw a straight line using that angle all the way through where the Earth supposedly would be below us. And if the Earth is a sphere, which is being affected by sunlight from another sphere, then theoretically, those two lines should always meet at the center of the sphere. Anyways, if we know the angle in two places, then we can draw lines from the surface of the Earth to the center of the Earth, or at least where those straight lines must converge to each other. This distance of that line is then approximately the radius of the Earth. We can now get the circumference of the Earth by using the equation for circumference of a circle, which is circumference is equivalent to 2 times the number pi times that radius squared. Now, this calculation assumes that the rays from the sun are parallel, since the source of sunlight is so far away. So this argument is slightly off, but it's still a really good approximation, especially for someone who just had basically a ruler. So like I said, this experiment was done in 240 BC, and it's really close to the actual circumference of the Earth. Like, it's only off by, I think, a couple thousand miles or something. And you can actually go out into your own backyard or front yard or whatever and do this experiment yourself. So you can pretty much set up like a flat, if you have like a flat pole, right? You can dig it into the ground, or you can just like hold it straight up, I suppose, and make sure that it's making a 90-degree angle to the ground. You can then pick a time of day and actually measure that length of the object itself, the length of the shadow, and then the length of that, or you can use trigonometry to get the length of the distance of that like shadow top portion of the triangle, right? And if you do this on different days of the year and you keep measuring it, you can actually get some idea of not only the circumference of the Earth, but also the circumference of the circle or the orbit the Earth makes around the sun. Like, you can get a lot of really interesting astronomical information from a piece of wood, I guess, or like plastic, just a flat piece of something, and a ruler, and some general mathematical know-how that you can learn on Wikipedia. So it's pretty sweet, and the fact that we can all do this in our own backyard means that all of us can pretty much disprove the flat Earth theory ourselves if we really wanted to. But besides these like geometric rules, which, I mean, geometry is kind of abstract and it uses math, and so it's not really like a perfect explanation or a perfect argument against this idea. Probably one of the biggest attacks, though, to the flat Earth theory was really our ability to sail around the globe and make sailing calculations based on the idea that the Earth must be spherical, using the same kind of principles that we just discussed. And all of the reports from sailors coming in to scholars and governments really made it clear that a flat Earth just couldn't be supported over time. Herodotus, the famous Greek historian, for example, in his histories, discusses a strange story of the sun sitting on the wrong side of a group of sailors as they were sailing past the equator. This concerned Herodotus because he didn't think that it should work, but it actually makes sense to modern readers who know that the Earth is spherical. I mean, if you're on one side of the equator versus the other, the equator being where the sun is directly overhead the Earth, then it makes perfect sense, right? If you're on one side of the equator, the Earth will be in a different position to the sun than if you're on the other side. And so therefore, the sun will appear to be either on the right side of your boat or on the left side of your boat as you're going in clockwise or counterclockwise directions. And as we got better at sailing, we found that we could in fact go all around the globe, circumnavigating it and making good calculations of how long trips should take, how far away things were, and where the sun and stars should be in the sky. And as my quantum mechanics for spectroscopy professor used to say, the proof is in the pudding. And in this case, there is so very much pudding, with such a quantity of proof, that it is almost embarrassing that people still believe the Earth is flat. So why do we think that the ancients had some idea about the flat Earth? Or rather, that this idea continued all the way up to the time of Christopher Columbus, for example? Modern views of this idea of a historical flat Earth seem to converge on the idea that this was mostly put out there as a way to discredit organized religion. Even during the Middle Ages, there just isn't a whole lot of evidence that supports the idea that learned peoples, and even theologians, believed that the Earth was flat. instead supporting the ideas passed down by the Greek philosophers, and continually improved and refined by scholars all around the world. This argument was made especially important during the time of the argument against creationism in lieu of evolution, where this idea of a simple-minded biblical scholar, arguing that the earth was flat and God made Adam from clay and Eve from a rib, was used to attack those in favor of creationism with basically a straw man argument that continues to be sort of believed today. Anyways, there isn't a lot of proof for this flat earth argument historically, besides in the far ancient history of the planet, significantly before the times of the ancient Greeks. By the time of the 14th century approximately, the idea of a flat earth just was completely gone from serious scholasticism. But it was in the popularization of the story of Christopher Columbus, and particularly the biography of him published by Washington Irving in 1828, that put this idea forward in really serious historical detail. Irving suggested that in the arguing before Columbus's trip, the more religiously fanatical members of the Spanish court argued with him that the Bible raised the idea of the earth being flat, and so his argument that it was spherical and that he could therefore sail around it was mistaken. This was just sort of a romantic twist put into the book, though, and the real argument was how big the earth was, not whether or not it was spherical. Alright, so historically there's very little argument about the earth being spherical really, at least for the last 700 years or so. So where did this modern day idea come from? If we look at the Flat Earth Society website, they claim that this idea mostly began when the governments of the world began to attempt to trick their people into believing that we had been into space. And we find that the farthest back their digital library of items goes is around the 70s, so it's possible that this is the case. Anyways, they think that the Flat Earth Truth movement sort of started, or really became obvious, with the trickery against the public that occurred during the space race. So that suggests, and it is in fact the case, that they think that the moon landing was faked. We've never been into space really, and all of this is a wide-ranging conspiracy to keep some evil, and probably cackling them, getting rich off of us. This is their response to the argument that people have actually been into space on their website. Quote, "The most commonly accepted explanation of this is that the space agencies of the world are involved in a conspiracy, faking space travel and exploration. This likely began during the Cold War's space race, in which the USSR and USA were obsessed with beating each other into space to the point that each faked their accomplishments in an attempt to keep pace with each other's supposed achievements. Since the end of the Cold War, however, the conspiracy is most likely motivated by greed rather than political gains, and using only some of their funding to continue to fake space travel saves a lot of money to embezzle for themselves. In light of the above, please note that we are not suggesting that space agencies are aware that the Earth is flat and actively covering the fact up. They depict the Earth as being round simply because that is what they expect it to be." End quote. They also state that they don't believe photographic evidence since it's so easy to trick around with. Okay, so then what is their evidence? They state the following, quote, "The evidence for a flat Earth is derived from many different facets of science and philosophy. The simplest is by relying on one's own senses to discern the true nature of the world around us. The world looks flat. The bottoms of clouds are flat. The movement of the sun. These are all examples of your senses telling you that we do not live on a spherical heliocentric world. This is using what's called an empirical approach, or an approach that relies on information from your senses. Alternatively, when using Descartes' method of Cartesian doubt to skeptically view the world around us, one quickly finds that the notion of a spherical world is the theory which has the burden of proof, and not flat Earth theory. Perhaps the best example of flat Earth proof is the Bedford Level experiment. In short, this was an experiment performed many times on a 6-mile stretch of water that proved the surface of the Earth to be flat. It did not conform to the curvature of the Earth that round Earth proponents teach. Many other experiments demonstrating the lack of curvature on the Earth may be found in Earth Not a Globe by Samuel Rowe Botham." End quote. Which is a little startling, frankly. I don't know if these guys read Descartes all that well, or all the way through, or the empiricists, but basically they are misusing both of them pretty badly. While it's true that Descartes claimed that the evidence of the senses was misleading, probably one of the best examples of that is the very fact that he discusses the problem of judging distance or shape from far away, For example, like on the surface of a giant sphere when you're a tiny, teeny dot on that sphere's surface. And like all of the best arguments against the flat earth come from good empirical science. So I'm not sure why they use these names here, unless to maybe try and give some legitimacy to their claims. And I'm sorry, as someone with a philosophy degree, I've just gotta like rag on this idea of using Descartes as an argument for anything except for what Descartes himself talked about. The whole, like, famous thing, this, like, Cartesian doubt that they're talking about with Descartes, ends up with the saying, cogito ergo sum, which means, I think, therefore I am. And that basically means that the only thing that Descartes felt could actually be known in the universe was that the consciousness of the person thinking must exist. And his argument was that the reason why that is the only thing that can be known, as opposed to like things that you see or empirically measure, was because there is always the possibility that your mind is playing tricks on you. So in other words, what you see or what appears to be the truth based on your senses is not necessarily true. That's the whole point of Descartes' entire philosophical treatise, practically. So they're just completely misusing it here. If anything, Descartes would say we can't know whether the Earth is flat or spherical. Not that because the spherical Earth uses measurements, it must be wrong. And then the empiricists themselves came out and said, well, Descartes himself was misunderstanding the nature of the universe. Because even though you yourself could be misled by, say, like a demon who came down and, was trying to trick you into believing things that were not true, which is actually one of Descartes' most famous arguments, the fact that multiple people come up with the same measurements gives credence to the idea of it being true. In other words, empirical measurements or empirical methods work because it's multiple consciousnesses coming up with a pragmatic truth about the universe. So, in other words, the experience of the individual is completely unimportant here. What is important is how well the measurements of the world conform to what actually works or what can actually be used in the sciences. And so, again, the flat earth theory just completely misuses these philosophers in their teachings. Anyways, what does the flat earth theory actually think then? They claim that the earth is actually a flat disk with a north pole at the center of the disk. At the edges of the disk sit what we claim to be Antarctica, which they claim is really a giant wall of ice, a la Game of Thrones, and which holds in the water of the oceans from whatever the hell is on the other side of the wall. The sun and the moon, therefore, float above the flat disk, sort of circling around the globe in a way that gives the day and night cycle. They don't believe in gravity, but instead in some kind of constant acceleration that brings us towards the disk itself. Which I don't know why they refuse to call it gravity, because it would be one less giant hurdle for them to pass to convince people that the damn Earth is flat, but whatever. Anyways, this idea is first seen in the literature in a book published in 1881 by Samuel Roe Botham, under the pseudonym Parallax. Just pro tip here. If you're getting your worldview from a guy that calls himself Parallax, bad call. The book is called Zetetic Astronomy, Earth Not a Globe, and proposed that this sort of ice wall circular model was the real one. So this book is the basis for most of their major arguments for how the Earth actually exists. And it's also, as they stated earlier, one of the major arguments for, it proposes all of the major scientific tests that they claim prove that the Earth is flat. One of their arguments seems to be that since the Earth is curved, we shouldn't be able to see very far with telescopes or something. Basically, that our line of sight should drop off. Which is something that we actually do see with boats on the horizon, for example, so I don't fully understand their point, maybe. And we know that the higher up you get, the farther away you can see. Something that, again, wouldn't be possible with an Earth that's just flat. In other words, of course, if you're on a flat plane and you go up, you should be able to see farther away than if you were on the bottom, just because of the angle you are, relative to the surface. But in fact, we can actually see farther than even that should make possible. and that is because the Earth is in fact a sphere and not a flat plane. One of their strongest arguments that they talked about earlier is supposedly the Bedford Level experiment, which if you follow the show on Instagram, you saw me solving with a pen and paper. So the experiment comes straight from that book published in 1881, and supposedly has not been solved according to the Flat Earth people, although it's actually been scientifically proven false over and over again. Anyways, the argument for the experiment goes like this. If the Earth is curved, then over a big enough distance, the drop in the height of the Earth's position should be noticeable. In other words, if we're on a sphere, then the farther away you get from your starting point, the more your distance should, in theory, drop like tangentially to that sphere. So they used a very straight river, the Old Bedford River, in fact, in Norfolk, England, and set up height markers at 6 feet over a 6-mile expanse in the river. And what they found was that when looking through a telescope, you could view all of those markers as lining up with one another, something that they believe should be impossible on a curved Earth. But, as with most experiments explained breathlessly in the same sentence as lizard people, they didn't take into account a number of very important factors. First off, the Earth has an atmosphere, and that atmosphere is pretty dense. And like light shining through a cup of water, the light from 2 points in the Earth's atmosphere will refract, causing things that are farther away from us to appear closer, and causing us to be able to see much farther towards the horizon than should theoretically be possible using just the geometry of the Earth's surface. But besides that, just how much of a drop should we expect over 6 miles of distance? They claim that it's something like 11 feet, but is that true? Well, doing all of the calculations myself, it was found that with an arc length of 6 miles, so the distance of the river, we should expect a drop of approximately 6 feet from the highest point of the arc, which is in the middle by definition. But let's not forget either just the sheer immenseness of the size of the Earth we're talking about. They took a 6-mile piece to call the Earth flat, while the radius of the Earth is 3,959 miles, and the circumference, or length around the whole outer circle of the Earth, is 24,901 miles. Which, by the way, that Greek philosopher earlier measured it to be around 24,000 miles. So, pretty damn good measurement by him. If we calculate how far someone could see if they are around 6 feet tall to the horizon of the Earth, it should be around 3 miles. And with refraction averages, it actually will end up being like 3.5 miles. That means that even with this experiment and taking like all of their numbers as correct, the error needed to account for a 6-mile difference in how far you actually can see is only a drop in elevation along that part of the river or that part of the land of like 3 to 6 feet given different changes in refraction with weather and everything. In other words, it is pretty easy for at some parts of the river to see farther than you expect, and at others to see less than you expect, since the margin of error is only like 3 feet along a 6-mile stretch. And as far as I can tell from topographical maps, the height of the river can vary between 1 to 2 meters or 3 to 6 feet up and down the river's length at any 2 points. So yeah, maybe a noticeable change in elevation standing on a river's edge looking down, but something that makes a big difference over sight of the horizon here. So the flat Earth isn't really that tenable of an idea. Besides these relatively simple errors in calculation and human error in terms of measurement making up for their biggest experimental proof to date, we also, of course, have pretty standard ways of seeing what the Earth looks like. For example, looking at pictures of the planet itself. And as Occam's razor tells us, we should usually go with the simplest explanation that fits all the facts available. And that explanation is that the Earth is round, as opposed to the shape of the Earth being kept from us due to some weird super conspiracy, which only the likes of superstar NBA players are brave enough to fight against in the public sphere. And again, like, with the invention and the continued use of other space propulsion systems and other rocketry technology, not made by world governments, but made by the likes of Elon Musk or, other companies trying to get us out into space, this idea of a flat Earth will just become continually untenable. I mean, once Elon Musk gets into space and then takes a photo of the Earth's shape, is he also in on the NASA conspiracy theory? What about that guy that sent that Lego minifigure up into space using a helium balloon? Like, there's just so much against the flat earth theory that it's pretty, like, for me at least, it's more interesting as a sociological phenomena and seeing why people don't believe pretty standard and accepted science versus it being like a really good anti-argument to modern scientific principles. Well, what are some of the other weird shapes of the Earth out there? Strangely, one of the most common versions of this theory that we find online, and by far Marie's favorite one, is the idea that the Earth is floating on the back of a gigantic turtle or tortoise. And again, not to go too crazy with the It's Always Sunny references in one episode, but we're not talking about like the Frank Reynolds floating on a turtle in outer space thing. This is a more serious version. All right? Seriously. This idea is pretty popularly attributed to the tribes of the northeastern and like just eastern sides of America. So not the American continent, but like literally America, the country. Particularly the region spanning from Delaware up towards northern New York and New England. A pretty good explanation of this idea, and its symbolic meaning, is found in a letter by J. Miller in the journal Man, published by the Royal Anthropological Institute of Great Britain and Ireland in 1974. The letter states the following, quote, "Sir, during his visit to the New World between 1678 and 1680, Jasper Dankarts recorded the most quoted account of the origin myth of the Delaware Indians of the eastern United States. I will paraphrase it. First there was only water, then the great turtle gradually rose above the water level and the creator placed mud on his shell. The mud dried and the great tree grew in the middle of the earth. As the tree grew towards the sky, Sprout became a man. Then the great tree bent down, and in touching the earth caused a sprout to become a woman. From this man and woman, all of humanity descended. The traditional Delaware belief that the earth rests on the back of a turtle is also shared by other tribes of the northeastern woodlands, most notably the Iroquois. The turtle is more than it appears. Speck noted that the turtle is the earth, is life. Speck saw this assertion based on qualities of the turtle that the Delaware admired in life: perseverance, longevity, and steadfastness. Also, the Delawares viewed all life, time, and turtles as continuously moving from east to west. Among the Delaware, one quality of life has priority. This is the quality of consciousness." End quote. He goes on to discuss how the turtle represents consciousness as well, a mixing of the mind and body, just as the turtle itself is like a mending of the earth and water since it is amphibious, and because it's omnivorous or it eats both plant and animal matter. There are other versions of this creation or cosmogony myth floating around too, with the turtle being a kind of common animal for this sort of like an animal is supporting the earth thing. I suppose it is this mixing of land and water duality, as well as the animal's noted longevity and steadfastness, that make it a pretty good animal to seem to be part of the planet itself. It also sort of can be easily mistaken for a rock, I guess, so I think it fits pretty well. The turtle supporting the earth itself isn't really taken so seriously anymore, but it really is only slightly more silly than the idea of the flat earth idea. I mean, according to the Flat Earth Society, we don't really know what's on the other side of the ice wall, right? Could it be turtles as far as the eye can see? Which I would be all for, by the way. Turtles and tortoises are straight up adorable. Maybe my favorite, somewhat more modern version of this sort of thinking is that the Earth isn't flat, but it's hollow. This myth shows up all the time on Ancient Aliens, with just as many supposed ways to get into the hollow Earth as there are groups or alien races or whatever who are living down there. Or at the very least staying down there until they can plot the destruction of the rest of us. You've got the Denver Airport, Area 51, the Marianas Trench, the Bermuda Triangle, the North Pole, the South Pole, the East Pole, the West Pole. Shit, there's probably an upcoming episode claiming that the Polish guy down at your local pub might just be the pole with the hidden bunker secrets. The argument basically states that the Earth itself has an outer shell where we live, and then some secret underground society that is basically living there with no interference from us, but who may or may not be trying to get back up here to do experiments on all of our mutilated cattle. This idea goes back a long way. I mean, it's not that far off from the idea of hell or an underworld, really. But in less religious views, probably one of the first scientific positions for the Hollow Earth came from Edmund Halley. He suggested in 1692 that the Earth may potentially be composed of two concentric shells with an atmosphere in between each shell. But this was posited as a method to explain experimental errors in magnetic compasses and things, and he didn't say anything about civilizations or, secret bunkers or stuff. It wasn't until later on in, the 18th and 19th centuries that people started taking this potential idea more seriously. And just like the ancient astronaut theorists of today, one of the major reasons that this was taken seriously at all was because some people can't discern mythology from reality. In 1781, Leclerc Milfort began an expedition into caverns near the Red River junction with the Mississippi River. This was primarily undertaken on the belief of the Creek Indians in the area, who had a myth about where they came from. They suggested that they came from the Earth, and more specifically from a subterranean Earth layer underneath our own, which is connected to the top by these caverns. Again, this idea is pretty common in tribal mythologies, with similar stories appearing across South America as well, and frankly, appearing in our own religious beliefs today to some extent. Anyways, they went on this expedition, and what do you know, didn't find the entrance to the underworld. But they did claim that the caves were pretty big, so I guess there's that. But these weren't the only proposed expeditions to find the Hollow Earth center. John Kelv Sims Jr. suggested that we could get to the Hollow Earth via the North or South Poles. He even wanted to set an expedition up, but the kibosh was put on that one by the US government refusing to fund the trip. But his ideas were really important to this field. He released various circulars and pamphlets arguing his point, the first one which contains the famous quote, "I declare the earth is hollow and habitable within, containing a number of solid concentric spheres, one within the other, and that it is open at the poles 12 or 16 degrees. I pledge my life in support of this truth, and am ready to explore the hollow if the world will support and aid me in the undertaking." End quote. His idea is sort of different than what we think of with the Hollow Earth. He thought that the transition at the poles was so slight that we wouldn't even know we were falling into the center per se, but instead sort of sailing on one continuous, never-ending kind of like Earth donut. He started off with 5 of these sort of spheres, but when that argument became untenable, instead just kept to a single sphere donut sort of weird thing. I guess more like a flattened donut sort of shape. Maybe more of a bagel or croissant. You get the idea. Some kind of buttery and delicious Earth pastry. He thought, in fact, that all planets were composed this way, and eventually his idea went on to spawn a whole bunch of Hollow Earth sort of ideas. His giant polar holes became known as sim holes. His son, though, kept his work up, and even erected a monument to his father, which still stands today in Hamilton, Ohio. Another person who is often referred to as being a Hollow Earth proponent is Leonhard Euler, who is seriously one of my favorite mathematicians, and so his inclusion in Hollow Earth theory is pretty annoying. Euler discovered half the stuff we need to make modern differential equations work, and has so much stuff named after him that we might as well call anything past Calculus 1 Euler and Friends. Anyways, there is absolutely no evidence that Euler really believed in the Hollow Earth. Instead, he just sort of maybe used it as a thought experiment, although there isn't super good evidence on that count either. Anyways, if someone states definitively that Euler believed in the Hollow Earth, then it means they're probably not trying super hard at their research, or they just are misinformed. There really is no evidence that Euler thought this, and that kind of makes me feel a little bit better. Okay, so this finally gets us to Sean's question. How do we know that the Earth is solid in the first place? Well, we can pretty definitively rule out Sims holes at the poles, since plenty of people have been to the poles, and also since we have taken pictures of the poles. Although if the last hour of podcast has proven anything, it's that the only thing which will seemingly convince people of the shape of the Earth is either a badly written WordPress article or seeing the stupid thing itself from space. For the inside of the Earth, a lot of our evidence is circumstantial, but not circumstantial in the he said, she said sort of way, more in the every single experiment we've ever done confirms these assumptions about the makeup of the Earth sort of way. First off, what is the current view of the Earth's makeup? Well, first we have the crust, which is around 0 to 25 kilometers in depth. This is mostly silica and other sorts of rocks and minerals. Next we have the mantle, which is from 35 to 2,890 kilometers deep. This is made up of sort of flowy, ductile, but still solid silica, with some iron and magnesium present within the silicates as well. The mantle is what allows the tectonic plates to move, and it's the heat from the core, as well as convection up the mantle, that makes the extremely slowly flowing silica rocks move the continental plates. Anyways, after the mantle we get to the core. The core is made up of iron and a small amount of nickel as we currently understand it, with a solid inner core and a liquid outer core. Whether or not the solid inner core is crystalline iron is still up for debate, but tests seem to support the idea that it is crystalline. Regardless, this is the general idea of the Earth's composition. So how do we have any idea about this composition? Well, number one, we can measure some of the compositions of stuff here by actually digging it up in some cases, or by looking at composition of material that flows up from lower geological sections by things like volcanoes. We can also collect samples from the bottom of the ocean floor, or look at areas where giant caverns exist that go much deeper into the Earth than we would be able to normally. Another thing we can do is collect indirect evidence, by testing things that should be the case given a certain composition of the Earth. So for example, we can get a rough idea of what is present in the center of the Earth by looking at the ways seismic waves propagate through the planet. This happens when we perform nuclear tests, when there is an earthquake, and when the tectonic plates of the planet shift around over time. If the Earth were hollow, it would be significantly more bouncy, for lack of a better term, than how it really behaves in practice, sort of like the difference between a lead ball and a tennis ball. We also know that there must be some significant amount of a magnetic material in the center of the Earth, because the Earth itself has a magnetic field, the flux of which coincides with how a giant core of iron would behave. We have an idea that the Earth must be composed of some heavy elements, and must be solid because of the way that it moves in space, the gravity that we have, and pretty much anything else that depends on the mass of the planet. In other words, a much less massive Earth would have a far smaller gravitational field. It would not move about the sun itself in the same way. Another thing we can look at to get some idea of the elemental composition of the Earth in general is to look at what elements we find and in what abundance. So the Earth has a lot of iron. We find a lot of silica. We find some magnesium and calcium and potassium and carbon and whatever. So it's probably a good bet that since those things compose most of the Earth's surface, there probably is plenty of it in the rest of the Earth as well. On the other hand, we don't find a whole lot of gold or silver or uranium, right? Rare elements are rare for a reason. And so it's more likely that those are coming from other sources or are only sparsely present within the inside of the Earth itself. That's why we kind of don't think the Earth has a golden center besides the magnetic arguments and the arguments with weight and stuff that we talked about already. Another sort of series of tests that we can do is to simulate the conditions we expect at the center of the Earth or at various levels. For instance, by applying high heats and high pressures to material here in labs on the surface to see what sort of material properties will result down there in the crust or the core or whatever. This is, for example, how we make laboratory diamonds, how we have some idea about how oil is made from organic material, and the sorts of metal crystals that might compose the inner core. Ultimately, we have a huge amount of evidence that suggests our assumptions about the Earth being solid are correct, since all of our mathematics and all the science built around those assumptions work. But we don't have direct evidence just yet of what the core is like, because we just can't reach it. The farthest anyone has gone to the core is 12 kilometers down, which means not super far. But again, the evidence for the Earth being solid is just as good as the evidence for things like evolution, gravity, electrons, and all kinds of other stuff that we just take for granted as existing. And there's other circumstantial evidence too, we don't have time to go over all of it. But for instance, astrophysicists can see and get a general idea of how planets form in other solar systems or just out there in space by kind of observing them, or observing how planets are forming over time, or, seeing something be destroyed and then start to condense around a center of gravity. There's, again, a lot of circumstantial evidence here that makes sense based on what we know about everything else in the universe. That's it for this week's episode. Thank you again so much for listening. This week's musical outro comes from the third album of Debajo del Agua. The song is called La Primera. It comes from their album Art Cura, which means Art Cures. I really love their stuff. They are extremely musically talented, and you can hear the love for music that comes through in all of their albums. This particular album is about the different ways music can help us heal and get through different points in our life. But honestly, all of their music is worth giving a listen to. I haven't heard a bad song yet. This particular album will be coming out soon, but you can find all their old stuff on Bandcamp, Spotify, and iTunes. Here's Debajo del Agua with La Primera.
Running from the tortoise and you with the hare in the end, who the fuck won? They on top, but what goes up must, you know the rest, but who do you trust? It's like a game of chess and I'm in checkmate, but I'ma hop off this board to make a getaway to escape this escapade. And every day let us create a better day, a better way than a lake of illusion, inundating my spirit with hate and confusion. Bullshit, nothingness and complacency, with a hole in the chest and a sign that said vacancy. What are you running to and running from? What are you running to and running from? Walking down the street, strolling on my own 2 feet, while the dome pieces flow into a hip-hop beat. No need for a sound monitor mics to even acknowledge earth tones. What seems to be like 1,000 kilometers of rhythms in the bones, when chilling in my own zone, smoking on the stove fumes, fucking up the ozone. Don't know how come the world so foul, rotten smell of inequality, a little brown child out of malnutrition down in Southeast Asia on a cotton plantation in the country called Malaysia, where the fly kicks that you rockin' made it. But was that fly shirt that you rockin' made it? The price tag high, but the price of life doesn't come in dollar signs, it come in grief and strife. Hollow following the blind, don't believe your own hype. An enslaved person probably made those nights. I said an enslaved person probably made those nights. The oppression that you hate is trying to bleach you white. So I say it as I see it and I don't have time. Justify lies given by a white collar crime. Enemies in you and in me, but when I walk the streets I don't see enemies, I see 10 of me. Little revolutionaries pretending to be thugs, mischannel hate in the face of a mean mug. We need love and peace, but overall we need equality and justice. Fuck the beast, we need equality and justice. Fuck the beast, we need equality and justice. Fuck this. What are you running to and running from? 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 Listen to the wind communicate spirit and breath. Listen to the rain pouring on the cracked cement. See the heat turn humid and the clouds turn gray. Burn sage incense, learn it day by day. I stay open and observe purity of fresh water flowing down a curb. Go from feeling blessed to feeling wrecked, getting restless. Flow as if it was my last breath. Now I'm breathless, breath to heal, but not limited to a section. Feel it in the soul, to me that's perfection. Music is my refuge from all the pain. Fuck the world, actually fuck the chains wrapped around the mental. Eyes in the back of my dome, and my tempo is hold and the mind is home. Metronome in the dome won't stop. Infinite polyrhythms like you're not now the herd of the pasture's flock. You can follow leader, get the fuck out the way. As for me, I prefer to dismantle this master's lock. And this insanity is how I stay sane. Maintain, not the type that would complain or complain, but it saddens me to say the world's on a shortcut, driving the wrong way, down a one-way bus, got a broke brake, so I still maintain. What are you running to and running from? What are you running to and running from? People are drowning in a lake of illusion, blind to the lies. We need to rise above this state of confusion. Waiting for a revolution is not gonna get you far. Know who I am, but do you know who you are? Here to go, open your eyes, cause people are drowning in a lake of illusion, blind to the lies. Need to rise above this state of confusion. Waiting for a revolution is not gonna get you far. I know who I am, but do you know who you are?